Do we need any more time on this? Where's my microphone?
Yeah, I just don't know what to do.
We don't know what we're doing. You want more time, or do you want me to go through?
I just did this.
You just made the axes so far? Would you like me to go through it? Or would you like me to go through it?
Why is it on the last one?
Okay, so let's start with x equals -3. The little highlighted pieces at the top should be a clue. Is that a vertical or a horizontal line? Is a vertical line. Here's how I remember it. It goes through that axis. So if you see x equals, it crosses the x-axis at -3, okay? Or if you see y equals, it crosses the y-axis at that value in the radius. So I make a point on my x-axis at -3, draw my line up and down with arrows, as straight as possible, and there is my vertical line. Questions? Okay, so y equals 7 is going to be what kind of line? Horizontal line. Goes through the y-axis at 7. And then the last one, this is y equals mx plus b, slope-intercept form. If you're going to graph it, what do you graph first? 4 on the y-axis. And then how do I graph a slope of -1/3? Right, so we're thinking of it as rise over run. Rise is a little deceiving because it could be like a rise or a fall, depending on if it's positive or negative. So we're going to fall 1, and then we're always going to run to the right. So it should look something like that. And of course, for right now, you can check all this in your calculator except for the x equals 1. Any questions? Graphing lines. Amazing. Okay, let's finish up our 2-3 lesson then. Let's try these together. For the following problems, find an equation in slope-intercept form that satisfies the given conditions. If it's a vertical line, we won't have slope-intercept form. It'll just be x equals a number. All right, so you saw some problems like this yesterday with 2 points. If you have 2 points, what do you do first? Slope. Okay. Slope equals. What's the numerator going to be for my slope formula? Y minus y. 3 minus 3. Denominator? 3 minus -1, so 3 plus 1. So now 0 over 4, which means what? 0. Okay, so my slope is 0. Does that mean this line doesn't exist? Even if I get an undefined value at this point, it doesn't mean the line doesn't exist. Never ever write that the line doesn't exist. If I give you 2 points, you can always make a line between those 2 points, okay? It just means it's a special case. So slope of 0, think about slope dude from yesterday. Slope of 0 is what kind of line? Horizontal lines. Horizontal lines have what kind of equation? What axes do they go through? Y. So y equals, look at those points. What does y equal in the points? Did I have to do any of this work, by the way? No. If you have a y coordinate or an x coordinate that doesn't change, that means that they're at the same height or at the same left-right value on your axis. So it's vertical or horizontal. But if you don't recognize it, you could do the work and the slope formula will give it away. You'll get a 0 either in the numerator or denominator. Second one, we want a vertical line through 5, 7. Vertical lines, think about it in your brain, has what kind of equation? X equals, and what does x equal? That's it. This should be the easiest ones. What was that? Ignore the beeping. It's fine.
Whenever this is like a vertical line, it should be x.
Vertical line will always be x equals horizontal. Yeah, if this said a horizontal line through 5, 7, it would be y equals 7. Did I tell you what that beeping is yet? It does it like all the time, all day long. So I have tornado shutters over on those windows there. See the cords that are coming down? So if there was ever a tornado, this is a tornado safe room, there's a keyhole in the back wall. I have a key, and these, I turn it, and then these like giant metal blinds come down. So that beeping is the battery in them. It's not the battery's going dead, it just beeps. It just is, that's what it is. So it just beeps randomly all the time. So yeah. All right. Ooh, the formatting's messed up here. I don't know how that happened. Okay. So something happened with my typing, but general form of a line. This is the only one we didn't talk about yesterday. General form of a line is ax plus by plus c equals 0. Pretty much it's where everything's on one side of the equation. Your x's, your y's, your constants. General form is ax plus by plus c equals 0. When you did this before in algebra 2, you probably had like capital letters for this equation. Ax plus by equals c is the version that the old book uses. This is the version that our book uses. Okay. All right, so we're going to start with this problem. Write a little bigger for you. 3x plus 4y minus 24 equals 0. We need to find some information here. See if I can do that and just scroll down. There we go. I want to know the slope. I want to know the y-intercept. And I want to know the x-intercept. Okay. How could I get the slope of this line? What's going to be the easiest thing to do?
I just turn it into slope intercept form.
Okay, so get the, what are we isolating? So y by itself. If you get the y by itself, you have slope intercept form, which is actually going to give you two of these answers. It's going to tell you slope, and it's going to tell you the y-intercept. So to get the y alone, I'm going to move the 3x and the 24 over to the right side. So it'll be 4y equals, it'll be a negative 3x, and a positive 24, and then I just need to divide everything by 4. And then reduce if you can. So I'm going to end up with y equals negative 3/4 x plus 6. So what is my slope? Negative 3/4 is the slope, and my y-intercept is 6. Okay, so I have those. X-intercept's the only one you're not going to get by doing this. How do we find an x-intercept? That's reviewed from one of our previous sections. How do you find an x-intercept? So, yep, you let y equal 0, and then you solve for x. You can use either the original equation or you can use the slope-intercept form. I'm just going to use the original equation. If I plug 0 in for y, everybody agree that that 4y term is just going to disappear? Okay, so then I have 3x minus 24 equals 0. Add 24, divide by 3, x equals 8 is the x-intercept. And you'll get that same thing if you solve using that slope-intercept form if you want to do that. Questions on general form of a line. Super easy? Good. Okay. Parallel and perpendicular lines. What do we need to write down about this? Let's see. Parallel lines have the same slope. We're using m's here, again, for slope. So m sub 1 and m sub 2 come from two respective lines, L1 and L2. Parallel lines have the same slope, which means on a graph they never what? Intersect. If we have perpendicular lines, well, what do those look like on a graph? Let's start with that. What is this? This is like the international symbol for they cross at a right angle. Okay. They're probably what you learned about them before is that their slopes are opposite reciprocals, which means you can take the slope, flip it, and change the sign, positive to negative or negative to positive, and then you'll have the slope of a perpendicular line. The problem with that is that only works if you have a fraction, a rational number for the slope. What if I told you the slope was the square root of 2? Okay, that becomes more of an issue. So an easier way to tell that you have parallel lines is this quick little math. If you multiply the slopes and you get -1, that's what happens with opposite reciprocals. So that tells you have a perpendicular line. Okay? So if the slopes multiply to -1, you have perpendicular lines. It's a better definition. And then, of course, horizontal lines are parallel to horizontal lines, vertical are parallel to vertical, horizontal and vertical are perpendicular to one another. All right, so I'm going to give you a couple minutes. What does it look like here? Well, go ahead and do all 3 of these. Try these with your groups, partners, whoever you want to work with. For the top 2, you're going to see some problems like this in Math Excel. You're going to be given a couple equations, and you have to decide, are they parallel, are they perpendicular, or neither? So what part of the equation are you going to be focusing on? Slope is what's most important. You need to find the slopes and compare them. And then I want you to see what you can do with the bottom one. Okay, I'll give you a couple minutes, then we'll come back together and talk about them. Okay, so for this problem, it says the computer company keeps a careful record of weekly advertising expenses and the number of computers it sells for the following week. The table below shows the data for the company that the company collected. Notice, by the way, these say in thousands of dollars. So it's another case where they're cutting off numbers that are repeated in every single value. So like when we see 100, it's truly $100,000 in sales the company's making, but doesn't make our number so large if we cut out those extra zeros. Same thing here. Sales the following week. So this is the number of computer sales. So 21 instead of 21,000 you're seeing there. All right, first thing is, yep, we're going to get there. So we're going to go to Stat. And then we're going to hit enter for edits. You probably have data in there already from last time, so you're going to go up to the list name, hit clear, and go back down, and that'll clear out the column for you. Make sure you all have an L1 and an L2. Let me know if you do not have an L1 and an L2. So what? Okay, hit stat, 5, enter. Okay, so now go back. Stat edit.
Are you supposed to press clear or not?
Clear. Clear. You don't even touch delete. Just stay away from delete. It's good that you don't know where that is. Right. Then the whole list disappears and we have to reset a calculator to make the list reappear. Did you do that?
No.
Oh, okay. We can reset it. It's okay.
Sorry, my first part of it was something funny to say when it didn't happen.
All right. Does everybody have the data in there that you need? Yeah? Okay. Have you guys done this before? Found a line of best fit in the calculator? Okay, we're gonna find out. All right, go back into your stat menu. We want our graphing calculator to make an equation that best represents this data. We're gonna go over to calculate. Instead of putting our data in, we're gonna have it calculate something. You can see there's all kinds of regressions here. Right now we are focused on a linear regression, which is number 4. And you can see your calculator uses AX plus B instead of MX plus B, but it's going to give us something in slope-intercept form. So just hit 4. And then you can see, this is why it was important you had an L1 and an L2. Those should be in there already. You're just going to keep hitting enter until you get to calculate and it does something. And something like this should appear. You might even have R's on there. We're not worried about the R's right now. Do we have it? Okay, we'll put the R's back in if we ever need them, but at this point you don't need them. Okay, so what is the slope of the line? 0.094, and you're probably going to give it a few decimal places, and then the y-intercept is that 10.333. Okay? So, if I wanted to find the equation, I'll just write it down, 0.094x plus 10.333. At that point, you could even do part C and part D. So for example, you can use that equation to estimate how many computers will be sold if the company spends $700,000 on advertising. Was advertising an X or a Y in this problem? It was an X. So what would you plug in for X? 700. Remember, we're cutting off those extra zeros, and then you would evaluate and solve for Y, and that would be your answer. And again, you would add a couple zeros, 3 zeros to the end of it to make it thousands of dollars. D, how much would the company need to spend on advertising if they want to sell 100,000 computers next week? Computers was what variable? The Y. So what would you plug in for Y to answer that question? 100, and then again, you would solve for X, and then add 3 zeros to the end of it because it represents thousands. Last thing we're going to do in the calculator is get a picture of the data with the line of best fit. So go into y equals, and we're going to turn our plot back on, like mine is right now. If your plot is not on, go up to plot, hit enter, go back down. And we're going to type that equation in we just had a second ago. It was 0.094
Yeah.
x plus 10.333. Again, a few decimal places, more decimal places, the better your picture is going to be. Do you remember what zoom to use to see a scatter plot? Zoom 9, zoom stat. Zoom 6 is your default. That'll reset it. But zoom 9, and I might have something else happening on mine, but you should see 6 data values and a nice pretty line on there. Okay. Are yours connected like this one? Hold on. Let's go into stat plot. Second y equals. Oh, we had it changed to a line graph from before. Hit second y equals. Enter. And let's just make it a scatter plot again. Instead of a line graph. Now hit graph. Maybe that's better. That's why I was doing that.
But still just a straight line.
Well, it should be a line because we are graphing that line. Zoom 9. Your plot on. For y equals. It's plot highlighted. It's plot highlighted at the top. No.
Okay, now let's see.
Now zoom 9. We got it. We got it. Everybody able to get a picture that looks something like this? Okay. All right, and then of course you can sketch that if you needed to, or match it on MathXL or something like that. All right, that is it for section 2-3. Do you have any questions for me? No? Okay. So 2-2 is due tomorrow night by midnight. 2-3 is due the 3rd, which what day is that? Tuesday next week? Okay, so you'll have a few days for that one then, okay? All right, last 10 minutes are yours. I'll do the cell phone lotto. If you want to be working on any MathXL or anything, go for it. Don't forget, tomorrow is the last day for gum, tissues, calculator, TI points, any of those things.